Okay, so for the first part of the workshop today, I refer to the task that I have finished yesterday in GeoGebra, right? And try to see how it will work now. If you look at my resource list, so you can see the first file that I made today, the cone surface. Okay, so that's the one I intend to create yesterday. You can open it later if you can't find it now, right? I just created this today. Right? And then you can see that I hope that you can make use of the several graphic windows. Right? So this one, and then also the 3D graphic window, and also the algebra window. Okay? Now you can check the objects here. Basically, we start with some points. Here are the points. Right, so I start with A, B, C. A is here, the origin, and B is a 3 point. Okay, originally a 3 point, but I then attach it to a curve here. Okay, and C is the center of the base. Just put it on the y-axis. Okay, and based on this, I create a point D in another graphic window. This is the point D. Okay, point D is based on x coordinates of B. Right. Together with calculation pi now L, all right? I now use the label here. I will show you where are the L, R and L, right? It is marked here on the graph, right? R and L is not marked, but I can put it there as well, right? Here and F are just 2 points to indicate more clearly the value on the axis, okay? So you can see the radius and also this is surface area. And you can see that for a fixed volume, okay? And there's a point where you can expect the smallest, the minimum surface area. Okay? So that is what I want to show. It's also a kind of modeling again. Okay, try to study the relations between different variables, particularly if you have certain constraints on this. Okay? So that is the kind of question I like to demonstrate. Right? And later on, maybe you can consider if you are handling similar physical problem or geometric problems, okay, could it be presented in this form and also discussed with the student? Okay, so that is the original the diagram I want to create. Okay, now where are the segment? You can see this. The segment R, right? It's just segment CB. I label it as R. Okay, and then I can use it for calculation. Right? I can use the label for calculation as well because it's the name of the segment. Right? And then you also represent the length of the segment as well. Now similarly, H is just another segment AC. Can you see it? Right? But at the same time, you can make it to use it for the calculation. Right? That's why in the calculations of the surface area, I can just directly input H there. Right? H times R, not H. Right? Is L, right? The slant length, which is represented in another part. I'll show you there. Okay. So V, the volume, is just a free value that you can just free yourself. And L is the later one created by this relation. Okay, the square root of R squared plus H squared. Okay. So that's L will be the slant edge or slant height of the cone. Understand? So once you have this number, then you can go on to calculate up. So sorry, I think where else? Okay. Yeah, that is the equation describing the constraint. Okay. So now for the equation, I have to use x and y because I put it back in the graph paper. Right. That's why I still use the x and y. So pi over 3 times x squared times y equals to v. That will give you the curve, right? Tell you what happens if v is given, and then how can x and y be varied. Actually, here the x and y represent the radius and the height of the cone. Okay, and the locus. Okay, later on, if you have the point D, then you can create a locus, which describes the movement of D based on the independent point B. Okay, so that is the command. Can you follow? There's something like this. So I think I show you, yes, more or less. And all then you can put this together, right, into one graph and just study it. So later on, if you change the volume, you can also try to further guess, okay, how would the minimum of the surface area change, okay? So you can further think about it. What determines the minimum surface area, right? Not specific value of probably there should be the shape, a certain shape you expect, right? So which perhaps will give a minimum surface area, okay? So you can also further study this. Now maybe I demonstrate quickly. I hope that this is successful this time, okay? So I try to demonstrate quickly how we can create such a graph. If you'd like to try it with me, you can open the file, GeoGebra Classic. Right, so to begin with, you can use the graphing area. I think that is the basic one. Okay. So we start with the 2D, okay, 2D pictures of the triangle. Okay, and then we use it to create the cone later on. So you can start with the center. I mean the origin. You can put the point A at the origin. By the way, if you want to fix it, yes, you can choose to fix the object, okay? So that you won't move the point accidentally later. Okay? So on the other hand, you can make a point B to be 3 point. That point B will be 3 point. Right? But A is fixed. And then you create a point C on the y-axis. Okay, can you follow? And you can also join them with segment. Now for AC, I still create a segment, even though it's overlapped with the y-axis. So we have the segment F, G, and H. Segment CB, okay, is the radius. So I would like to rename it. If you open the setting, then you can rename it. You directly rename it as R. Okay, so directly rename it as R. Enter. So you can see the labels change here. That will be more convenient for illustration and calculation. Okay. So at the same time, you can also show the label, which is the name. That's why R is shown here now. All right. Now similarly, I would like to have AC equal to H. So I like to call this. So I now select another segment, CA. Okay. And now I call it H to represent the height. So notice that we already use another H. Okay, I think the GeoGebra will adjust the other name. Let me try. I enter it now. Okay, you see what happened. Okay, I call it H. Then this turn to H, but this now becomes H1. Okay, they just adjust the name automatically. Right. I will forget about the H1 here. By the way, I think I can also name the segment BA. Perhaps it's much better. I just call it L. Do you remember? Usually we use L in our formula to represent the slant height of the cone. Do you use the same letter usually? Yes. L stands for the length of the slant height of the cone. Okay. Okay. So I think it's even save one step because I don't even have to create a formula to create that value. Okay. I just forgot it. So I can now have a length L. So these are shown on the screen. Okay, so let's check it. Can you see this? The length L, R, although it's not very clearly shown, H here, we can also show the length. H length. So maybe you can also change the color to make it easily shown. Now, and further on this graph, I want to create the constraints, okay? Set up the volume. So I simply type V equals something, anything you like, 30, for example. We also set the range from 0 to, well, anything you like also, okay, 100, for example. And then give a step. If you also want to constrain the step, then put it here. And you can show the slider, okay? And so here, I put it somewhere here, so that it can be easily controlled. Okay? Now so far, the V is just a constant, right? I'm going to use it later, okay? And you can adjust to any value you like later on. Right? So it represents the volume. So the next thing is to create a curve that describes the relation between R and H based on the given volume. Right? So that's why I create a curve. Now yesterday I draw a function, but I remember that we can simply input an implicit equation. Okay, the implicit equation here means V equals directly like the formula. Okay, pi divided by 3. This is the constant, and then R squared H. But because I want to put it on the graph paper, then I still have to use the variable X and Y. Okay, so I suppose X represent radius. And then Y represent the height, right, of the cone. Okay. So see the graph now. Do you notice that? Okay. So that graph represent directly if V, the volume set to be 30, okay, then the R and H, that means X and Y, will be related this way. Okay? So that is the graph. So we can also change the color to mark it, or label, or change the color of the slide of V as well to demonstrate, okay, how they are related. So you can set the value somewhere around here. Okay. Now so far the point B is still free. Okay, so yesterday I demonstrated another new tool, attach. Right, so you can detach or attach. So you can also undo it. Right? That means you can put the free point on some object in order to make it a point on that object. It can be a line, a circle, another geometric object. Okay, and this part I put it on the graph. Okay, so I stick it to the graph. So I choose. I should choose the point and then the object to attach. Can you see the hits lower here? So I select the point. Okay, select the tool first. I select the tool. Now I click point B and then the curve. Okay? So you can grab the graph back here. And then now you find that the point B is now stick to the graph. Okay? So that will now the radius and the height will be constrained by this relation, right? So no matter how you drag the point B now, the volume of the cone will be fixed as 30. Okay? So that will also demonstrate in what way if you assign a constraint. So what happened to the rest, right, to the other variables? Now that is also very common when you study modeling problems. Do you agree? Right? When you set a constraint, then you see, oh, how come the other variables are related, or in what way they are now changing relatively to each other. All right. So far, any question? Okay. Well, now for the 3D graph, right, you would like to create a cone. Right? Now that is the part that you may want to also demonstrate. Okay, the cone as well. So it can be done with a command here as well. So if I type cone, then you can see the options. Okay. Now I type the command cone. You can see that you can just create a point, but it does not mention clearly which point it represents. I think the first point is the base center. The second point is the apex. Okay, as far as I remember. Otherwise, you just change it. Right. Try it again. And then the radius, right? So in that case, the base is the point, base radius is C. and the apex is A, okay? And the radius is simply R. I already set the link, right? The name of the link. Okay, so I try it and see whether it works. Right, can you see? I think it worked because it gives a number. And 30 is the volume actually. Right? Because we create a code and then tell you the volume as well. Right? Because it's also show you the numerical values associated to it. Alright, so I just press enter. Now, but it's not shown because you don't see the 3D graphic. Although the object is already created, right? However, you don't see the 3D graphic. And now, okay, now let's add the 3D graphic window. So that is the 3D graphic window. Sorry, not here. Perspective, right? Not the perspective, but the view. So that you can select the individual, right? Individual components. Right? So I now want to add the 3D graphic. Understand? Yes. Okay. Now, one more part. When you add the graphic, you see that now your window is very clumsy, very messy now. Okay, we have too many parts together. Okay, now let's move around the windows. Can you see this handle? Can you see this handle? I click on it and then drag it at the top. Because I like to put it this way. And if you want to, okay, adjust a little bit the width here, you can also do so. All right.
So where is the handle button again?
Now, when you start the menu, you can see the handle.
Oh,
you see the handle. But when you close the menu, you don't see it. Okay? So you can readjust it for any part you like. All right. So in fact, the 3D window is not so important in our case, but just to let you know that you can actually include it, right? If you want to see the real cone, right? If you want to see the real cone, and you can also see the curve. Actually, the graph is also there, right? And you can hide it if you want. So if I click on the graph, I mean the graph here, okay, the equation, and open the setting. Advanced, in the advanced tab, you can choose to show it on the 3D graphics or not. Okay, so you can hide it. So it's still here, but okay. Right now, the next step, the final step, I want to show the surface area as well. Okay, the surface area as another point in another graphic window. Okay, so here I go to the graphic tool. Okay, now I want to add graphic tool. Finally, just put it on the right. See how it works. Okay. So that is the graphic tool. Okay, now I add the point D on this graph. So you can label it anything you like. Okay, I just call it point D. The x value, x coordinate is based on x coordinates of B. Okay. And the surface, the y coordinate is the surface area. So I need pi r L. I think now it's fine now because I see all the values. Okay. So x coordinate of B, radius is 2.8. Okay. And this one is 40.5. I wonder, can I change it simply to R? Let's try. Okay, it also works. Okay, so create a point D where the x coordinate is R and the y coordinate is pi r L. Okay, so you have another point. Now, the point D, I suppose the point D should be here, okay? But you can't see it, right? Because maybe you have to adjust the scale. I just changed the y-axis manually, okay? Okay, until I got the point D. You see that? And so you can have a try with the point B. I think it works now. Okay? So the next thing I want to create will be the locus of the point. locus based on the point D, and then, well, that's combined, all right, over here. Locus of the point D, all right, according to the point B. B is the movable point. That will affect the point D, all right? And at the same time, B is also a point on a particular curve. Now that is also very important. If B is a totally free point, you cannot create a locus. Can you imagine? If D is totally free, then there's no locus at all, okay? Or maybe the locus is too, trivial, okay? Because it's just move around, okay? Yeah. Then it can be anywhere, right? So still, usually the locus should be a curve, right? So that means even the independent point, so-called independent point, is supposed to be constrained, in a particular way, right? Right. So that is the relation. Right, so now you see the locus. Oh, where is it? I check. Yes, as I put on the graphic D, but not in the graphic 1. Also not in 3D graphic. Okay, so I take away all these. I think it's better now. And you can give it a color. So maybe this I take it blue. Okay. At the same time, we can also adjust the graphic window. Okay. So including the color, if you still remember, you can actually change the color. Make like a graph paper. Or you can also change the grid color. I don't know whether
I think our curve looks way different by domain. It's like going from negative infinity to positive infinity.
Oh, what's wrong?
Oh, the D needs to be R.
Okay. That should be green in my screen. Okay. Okay. But now it's not the same because it looks like the traditional graphing paper. If you remember. Okay. Okay. Now can you see this? I still show part of it because I think the maybe so you can see that correspond to the visible part of X here on this side. Okay. So that's why it's only show part. If I change the range, I think it also will adjust. Maybe I just try it. All right. So now you see bigger range. All right. And the cone is here. Similarly, for the 3D wheel, you can also adjust the size. I just slide in the trackpad and to make it zoom in and out. Okay? That's why you can see the change. All right, now you can see the graph here, and then you can explore this. When would you have the minimum? When would you have the minimum? And you can adjust the volume. Do you notice that? If you adjust the volume, the whole curve will also change. All right, then you can still see when should be the minimum. Something like that. So now finally, I add 2 more points on the graphic window, second graphic window. Okay. Now I want to add 2 more points here to indicate more directly the values of the radius and also the surface area. Okay. So this is the radius and surface area. So how I do it? I add the point. Which is the point on the x-axis correspond to the. In fact, you can directly type R and 0. Okay. So there's two ways. One general way is to actually refer to the coordinates of t. X of t means x coordinate of t. But in my setting here, I already have a variable r. Okay, so I just type RL. So similarly, this one will be the surface area. I can do this calculation, or I can just refer to the y coordinates of t, which are already done. Okay? So another point on the y-axis will be 0, yt, okay? y of t. Then you can have another point here. Can you see that? And finally, you can join them together. And now adjust, maybe you can adjust it, adjust the style to make it a dotted line. And then the label. Now when you open the point E, okay, this is the name. But you can display the caption. Right? Maybe the caption, now I turn it into radius. So caption can be any label you want to display, but not necessarily the same as the name. Okay. So sometimes you need the name for other operations, right? Maybe other calculations as well. So don't change the name arbitrarily. Okay. But you can display what you want here. Okay, as another text, or even sometimes with some numerical values as well. Okay. So can you see this? So that's why the option here shows that you can display the caption. So here is the label. And similarly for the point M, I will like the caption surface area. All right. So I think it's better now. This is the surface area. This is the radius. Okay. So, all right. Luckily, this time it's quite smooth. Any questions? So I think you know how it works, right? So you can open my new files made in my under my account, right? Or I will put the links later together with the video for this part. So I think we can finish here, right, for this example, all right?